Okay, today we're going to do 10.3, which is ellipses. Ellipses are what you guys think of as ovals, but it's an oval with uniformity. There's a couple different things that we're going to look for on the ellipse. The first thing that we're going to look for is the center. And then we're going to look for if it's a vertical or horizontal ellipse. This one is a horizontal ellipse, meaning that the movement to the left and right is bigger than the movement up and down. Okay? We have to figure out what this movement is and what this movement is. Okay? When it's a horizontal ellipse like this, we call these the vertices. Vertices are your big movement. So your big movement is what you're looking for there. And then co-vertices are your little movement. This is right there. Co-vertices are just a little movement. And the same will be true with a vertical ellipse, but we're just looking at these right now. The next thing you're looking for are the foci. I'll explain in class what the foci actually are, but right now we just need to be able to find them. These are the foci. And I will explain this by showing you what it means, okay? So you'll be able to see this. So we got to look at our equation. The standard form of this is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. Okay? This is a horizontal ellipse, and then a vertical one. What happens is the x and the y's are gonna switch locations. So it's gonna be y minus k squared over a squared plus x minus h squared over b squared equals 1. Okay, so we're looking at this part. Notice that the a squared is always first, and it's always the larger number. Okay, how you find the foci is you're gonna do a squared minus b squared equals c squared. Your foci are gonna be, for this one, the foci is h plus and minus c comma k, and for this one it's h comma k plus or minus c. So that's what you're looking for on that one. Okay, so we got to find out all that information. If I give you an equation that tells you something like notice that on this it's still a plus, so that's why the ellipse is still coming together. So on our circle it was like a uniform amount of distance away, and it was a plus, making them come together. And then on an ellipse it's just the difference going up and down is different from the side to side, and that would be a horizontal, and then that would be a vertical one. Okay, so what we're looking at here, we want to figure out all of our information. We want to find the center, which is still h comma k. We want to find the vertices, which, because this one is horizontal, it's going to be h plus or minus a comma k. We want to find the co-vertices, which, because it's horizontal, it's going to be h comma k plus or minus b. And then we want to find the foci, which, because it's horizontal, it's going to be h plus or minus c comma k. So the first thing I'm going to do is the center. A is, oh, I did this backwards. I got to switch these around. I apologize. This needs to be 9, and this needs to be 4. So I'm going to do the square root of this. This is a squared, so that means that a equals 3. This is b squared, which means that b equals 2. To find c, I do a squared minus b squared equals c squared. So 9 minus 4 equals c squared, which is 5 equals c squared. So c equals the square root of 5. So now I'm just going to plug in everything I know. H is 2, so my center is at 2, comma, k is 3. My vertices are going to be at 2 plus 3, which is 5, comma 3, and 2 minus 3, which is negative 1, comma 3. So remember that your vertices on my picture were the movement left and right from the center. So the movement to the right was the +3, the movement to the left was the -3. The y value didn't change at all. It just went straight across. So that's why my vertices have both 3 and 3, like the sitter did. Co-vertices are going to be, the h is going to remain the same, but the k is going to change. So I'm going to do 3 plus 2, which is 5, and 3 minus 2, which is 1. And then the foci, the h is going to be what changes. So it's going to be 2 plus the square root of 3, square root of 5, and 2 minus the square root of 5. So I'm just going to write it as 2 plus or minus the square root of 5, comma 3. If I needed to graph it out, I would start with the center. Center at 2, 3. Vertices at 5, 3. 1, 2, 3. And negative 1, 3. Co-vertices at 2, 5. 2, 5. 1, 2. And 2, 1. And then the foci are going to be like right here and right here. I don't connect the foci. I'll explain the foci better in class, but I'm just going to connect the vertices and the co-vertices. And that's it. Okay? If I have a vertical one, the only difference between this on the vertical is that the bigger number would be under the y, which is how I had it originally. So the y should come first if the larger number is under the y, but it won't always. Sometimes because it's plus, you need to switch them around. But let's just assume it does. So let's say that we have y plus 2 squared over 16 plus x minus 1 squared over 9 equals 1. Okay, now we need to go through the process of making sure that we have all the information. So the center is usually where people make a mistake on these ones because they want to use this number first, but this is still your h. Remember when I wrote the equation? The k is still with the y, so the h is still with the x. So that means on this one, the center is going to be at 1, comma, negative 2. The vertices are going to be movement to the y this time. So what that means is my a value is square root of 16, which is 4. My b value is the square root of 9, which is 3. My c value is a squared minus b squared equals c squared, which gives me 7 equals c squared, which gives me c equals the square root of 7. So my vertices, the x is not going to change on the vertices. The y is. So I'm going to do negative 2 plus 4, which is 2, negative 2 minus 4, which is negative 6. Co-vertices, the y is going to be the same on the co-vertices. So I'm going to do 1 plus 3 is 4, 1 minus 3 is negative 2. And then the foci are going to happen to the y value. So I'm going to do negative 2 plus the square root of 7 and negative 2 minus the square root of 7. So since it's the square root, I'm actually just going to write plus and minus. Negative 2 plus and minus the square root of 7. And that's it. Hopefully that makes sense.